Good morning, everyone. I'm Bizot Flavien, and today I will present to you some data obtained during my PhD at the University of Versailles-Saint-Quentin-en-Yvelines in collaboration with Raymond Poincaré Hospital, Sky Therapeutics, and Initos Pharmaceutical. Today, we will see that oligonucleotide enhancing compound increased tricyclo-DNA mediated exon-skipping efficacy in the NDX mice model. Oligonucleotides is one of the most promising therapeutic strategies for Duchenne muscular dystrophy. Its potential is very big, but is still limited by some challenges, like the poor distribution of oligonucleotides to the target tissue, but also by the limited amount of oligonucleotides able to escape the endosomal compartment. Some small molecules named oligonucleotide enhancing compounds have been developed to improve the endosomal escape of oligonucleotides. In this study, we will evaluate the impact of the therapy combining oligonucleotides and an oligonucleotide enhancing compound in NDX mice model of Duchenne muscular dystrophy. So to investigate the effect of oligonucleotide enhancing compound named 7938, we perform a short-term study and we treat mice with oligonucleotides weekly during 4 weeks, as you can see here in blue, and 24 hours after each ASO injections, we perform a OEC injection. We sacrifice mice 2 weeks after the last ASO injections, and we analyze tissue. So when we focus on mRNA, we saw that there is a higher mRNA corrected level in the heart with the B therapy, as you can see here, on exon skipping level, but not in the other muscles. If you monitor the protein restorations level, we saw that there is more dystrophin restored in the heart and in the diaphragm, but not in the other skeletal muscles. So to better understand the effect of OEC, we perform a kinetics. So we still treat mice during 4 weeks, but we sacrifice them at 72 hours, 1 week, 3 weeks, and 6 weeks after the last oligonucleotide injections. So when we study the mRNA level, we saw that there is higher exon skipping level in the heart at the early time points, 72 hours and 1 week, but not at the last time points, like here at 6 weeks. The same effect has been shown in the diaphragm. When we study the protein restoration level, we saw more dystrophin produced at the early time points, 1 week and 3 weeks, but not at the last time points, 6 weeks, here, in the heart and in the diaphragm. So to assess the long-term effect of OEC on ASO therapy and to investigate the potential functional improvement, we treated mice during 12 weeks. After 12 weeks of treatment, the co-treatment of OEC and tricyclo-DNA has led to increased dystrophin restorations in the heart, here, in the diaphragm, and in the triceps, but not in the other skeletal muscles. When we assess the heart functions, we saw that the OEC combined with tricyclo-DNA is able to improve and to normalize the left ventricular ejection fraction here, the systolic pulse pressure here, and the fractional shortening here. So to conclude, we can say that the OEC increased the efficacy of tricyclo-DNA, especially in the herd of index mice, and the effect is particularly strong at the herd time point. The long-term combination of oligonucleotides and OEC treatment induce a higher level of dystrophin restorations in the herd and in the germline. Co-treatment of OEC and oligonucleotides for 3 months is able to normalize cardiac functions in the NDX mice. Thank you to have listened to me, and if you have any questions, don't hesitate to contact me on LinkedIn.